Now let's test for other than int type. So here we have int, but for m, let's change to double. And some integer is also double type, so the code should work fine. So as I compile the program and run, so program code runs fine. But as we have studied earlier, if you use equality using non-integer type, then you may get some errors. So for example here, as we add 5, now we can add 5.0 and the like. And then if we add 0.15 times, technically this is a 5.5, so we look up if it's correct or not, run, then we say that assertion failed, so that's not 5.5. So what is the value? The Visual Studio Code is the for constant definitions, Visual Studio Code has some runtime value you can look up immediately. So as you place the cursor over, what you get is something like this. So it's not exactly 0.1, but it's a 0.10000 because it's a double representation, floating point representation. So the value, this one is not exactly 5.5, but it will be 5.4999999 or 5.5000 and the like. So what you actually append is not exact. So when you compare floating point numbers, do not compare directly with the equal operator, but you should use the difference. So find the difference, absolute number, and then find the difference between the two. And then if the difference is small enough, then consider it as equal. So you can define const double e is something like 0. If a difference is less than something like that, then consider that's the same. That's what we learned earlier regarding the floating point number truncation. FABS is in CMath library. So you need to include the CMath library for that. Then as I compile and run, program runs. So you can use any type, but as you use a double type, non-integer type, don't use a two equal sign, equality, but make sure that you check the difference is small enough.